This is not a scrapyard. It is a manufacturing system running in reverse.
From up here, the secret becomes obvious. Recycling at this scale is not the end of manufacturing. It is the hidden beginning of it. Here, submarines, aircraft, and cars all arrive with different histories fondly, but they leave as material. The submarine does not disappear all at once. It comes apart in disciplined steps: lift, lower, reduce, repeat. The submarine does not disappear all at once. It comes apart in disciplined steps: lift, lower, reduce, repeat. For all the mass and machinery, this loop still depends on judgment: where to cut, what to keep, when to wait.
Even at night, the factory keeps separating history from material.
Inside, the work becomes intimate: cramped passages, old systems, and decades of sealed complexity. The submarine enters first, because the most dangerous machine must always be made safe before it becomes material.
Where a submarine once dominated the frame, only metal stock remains.
The submarine demands caution. The aircraft demands precision. The cars demand speed.
Now the streams merge. Marine steel, aerospace aluminum, and automotive metal all enter the same refining heart of the factory.
In another hall, the same recovered ferrous stream becomes panels for buildings, visible proof that recycled steel can return at the highest level.
Recovery is complete. Now transformation begins.
Premium is not just what a metal's. It is how perfectly that metal is finished.
Curved hull sections become cuttable steel. Structure becomes stock.
This is where scrap stops being scrap. Heat resets the story. Steel enters first: thick marine plate, automotive body steel, and all the ferrous mass this factory has recovered.
At the end of the car line, nothing resembles a vehicle. Everything resembles an input.
At the end of the car line, nothing resembles a vehicle. Everything resembles an input.
But shredding is only the midpoint. Real value appears in what the separation systems can recover next.
But shredding is only the midpoint. Real value appears in what the separation systems can recover next.
This factory is never only dismantling and never only manufacturing. It is always doing both.
This factory does not simply tear things apart. It reads them, sorts them, and turns complexity into recoverable order.
The same metal that once formed hull sections and car frames is being pressed into forms that modern industry can trust again.
The same material logic that mattered in the air now matters on the road: stiffness, balance, and efficiency. Now naval steel meets industrial fire, and a machine built to survive pressure begins to surrender to temperature.
At this stage, the material is tested not for where it came from, but for what it can become next.
Submarine, aircraft, cars, scrap, alloy, product. The chain is longer than it looks and tighter than it seems.
What entered as submarine shell and car body now leaves the furnace as clean steel cast into new geometry. What entered as submarine shell and car body now leaves the furnace as clean steel cast into new geometry. Inside the furnace, the factory is not merely melting metal. It is correcting, balancing, and rebuilding it. Inside the furnace, the factory is not merely melting metal. It is correcting, balancing, and rebuilding it.
At the heart of all this complexity are only a few materials, recovered, corrected, and sent back into circulation.
Aircraft skin, wheel hubs, and automotive alloys now cool as new billet silk. Standardized, trackable, and ready for precision manufacturing. Aircraft skin, wheel hubs, and automotive alloys now cool as new billet silk. Standardized, trackable, and ready for precision manufacturing.
Once the metals are clean and certified, the factory's second identity takes over. Not recycler, but maker.
By the end of the marine line, the submarine is no longer a vessel.
It is premium heavy-gauge steel waiting for its next life.
The first split is simple and powerful. Steel goes one way, everything else keeps moving.
War machines, flying machines, road machines, working. Every one of them now waits for the same industrial fate.
A submarine becomes steelware and structure. An aircraft becomes lightweight precision. Cars become the mass metal backbone of modern goods.
High above roads and oceans, this engine once turned air into force. Now it enters a new economy.
None of this scale works without data. Tonnage, alloy mix, energy use, recovery rate, and product traceability all flowing in parallel.
What once moved unseen beneath the ocean now hangs in plain daylight as segmented industrial mass.
A hull ring becomes a charge becomes molten steel, and molten steel becomes the base of something entirely new.
Every cut is matched by support. Every separation is controlled before it is visible.
From here on, the process stops looking like recycling and starts looking like manufacturing. Hazards leave first. Fluids, residues, protected components, clothing, anything that cannot meet the torch or shredder has to be removed.
Like the submarine, the plane is made safe first, but here the priority is access, inventory, and reclaim.
Outside, metal is still being broken down. Inside, it is already being perfected.
The recovered steel must prove it can hold form, hold finish, and hold value.
Recovered steel is no longer judged by what it was. It is judged by the finish it can hold, the durability it can prove, and the confidence it can sell.
What once held pressure under the sea now becomes a vessel for heat on a kitchen range.
This is the answer hidden at the end of the yard. Destruction was never the product. Transformation was. This is what scale looks like when it is measured not in machines received, but in material reborn. A premium good begins long before shaping. It begins when chemistry says yes.
Outside, metal is still being broken down. Inside, it is already being perfected.
At one end, force. At the other, finish. Everything in between is process.
This is where volume wins. The shredder does in seconds what manual labor could never do at scale.
The plane loses its profile one layer at a time, until what remains is pure structure.
The hottest part of the factory is also the cleanest point of beginning.
The loop does not end when the sun goes down. It simply changes color.
It takes different kinds of precision to make one loop work: thermal precision, sorting precision, and finishing precision.
Residual fuels, hydraulic fluids, and service chemicals are removed before a single panel is opened.
And sometimes, in one frame, you can see the entire idea. Hero. Raw scrap behind, finished value ahead. Certified, packed, ready to ship, and already replaced by the next machine entering the yard.
The same complex receives machines at one end and ships premium goods at the other.
What the market sees as premium often begins with something no one wanted anymore. What looked at first like scattered destruction is really one continuous geography of transformation.
Then come the engines, dense with alloys, engineering, and value concentrated into a single lift.
Recovered steel moves first into goods that demand durability, finish, and clean geometry.
The shape has changed. The purpose has changed. But the metal, purified and reworked, endures. The moment the load transfers, the aircraft changes. It is no longer a complete machine, but a shell surrendering its most critical organ. Inside the engine, the factory finds its real treasure: high-temperature alloys, precision-machined components, and metals too valuable to lose. Sometimes the smallest outputs carry the clearest proof of the factory's success, because the tighter the tolerance, the less room there is for compromise.
The flow begins with separation by hazard, by alloy, by value, and by the complexity of what each machine still contains.
Once the internals are cleared, the shell itself can finally be divided.
Everything here depends on motion, guided, measured, and repeated, until complexity gives way to flow.
For aircraft, traceability is everything. A part removed here may fly again somewhere else.
Copper recovered from control rooms, avionics, and vehicle looms now returns as clean electrical stock for products where failure is not tolerated.
A wire that begins in a dismantled machine can end in the circuitry of something far more refined.
And copper, once hidden in walls and wiring looms, returns as clean conductive stock for the products that demand reliability.
Some premium goods hide their value inside, in the conductors, the signal paths, and the consistency of every electrical connection.
Premium performance often comes from metals the customer never sees.
And copper, perhaps the least visible metal in the story, may be the most important at the finish.
And copper mat, pulled from control systems, aircraft harnesses, and car looms head, is treated as a premium stream all by itself. And copper mat, pulled from control systems, aircraft harnesses, and car looms head, is treated as a premium stream all by itself.
And in the copper line, performance is not visible at all, until the instruments confirm it.
Copper, aluminum, and mixed alloys are no longer waste. In a factory like this, even fines become revenue. Premium goods do not get a lower standard because of where the metal came from. They face a higher one.
What ships out today is made possible by what charges in tonight.
At the very end, value becomes visible in the simplest way. A finished object an East Asian female person can hold. Not everything flies toward the furnace. Composites, polymers, and engineered laminates take their own route through the plant. The cockpit is treated like an electronics vault, every module documented, every connector cleared, every part handled like inventory. This is where repetition replaces rarity. A constant river of steel, aluminum, glass, rubber, and wiring. If aircraft are valuable by part, cars are powerful by volume. Here, the factory consumes not one giant machine, but thousands of smaller ones.
Like every machine in this factory, a car is made safe before it is made small. Like every machine in this factory, a car is made safe before it is made small.
Even the most violent stage in the factory is only a bridge. On the other side is order, chemistry, and controlled geometry. Some cars die in parts, others go whole to the shredder. The factory decides based on value, damage, and speed.
Even before cutting starts, the submarine is already becoming copper, steel, salvage, and waste.
The old machine is never literally inside the new one, but its material, recovered with enough discipline, can still inherit a second excellence.
The metal that arrived nameless leaves with a model number, a finish code, and a place in the premium market.
Aluminum remelting is quieter, cleaner, and far more selective, because premium aluminum depends on alloy discipline.
Recovered alloy can also move into the smallest premium formats, where tolerance, finish, and consistency matter more than size.
Precision housings, polished surfaces, and tight tolerances bred. This is where recycled alloy sheds every last trace of its former life.
There is no visible trace of the aircraft or car left behind, only surface quality and engineered form.
Premium aluminum is not only light, it is surface-treated, refined, and made to look as precise as it performs.
Premium aluminum is light only because it has been made strong enough to afford that lightness.
Then the non-ferrous line takes over, throwing aluminum clear from the stream through invisible electromagnetic force.
Aluminum takes another path. Lighter, more sensitive, and more dependent in alloy control, it moves toward its own precision melt.
Aircraft aluminum, once optimized to fly,
now finds its next life in products built around strength without weight.
Recovered aluminum now moves toward the kinds of shapes premium goods depend on: light, strong, and dimensionally exact.
Recovered aluminum does not have to look recycled. At its best, it looks engineered.
Material once trusted to fly can still be trusted to perform if the factory knows how to recover it.
Once the high-value systems are clear, the airframe itself begins to open. Skins, ribs, brackets, and miles of embedded wiring.
In the aerospace zone, the rules change. Here, weight saved in the air becomes value recovered on the ground. In the aerospace zone, the rules change. Here, weight saved in the air becomes value recovered on the ground. Unlike the submarine's tight steel corridors, the aircraft opens as a layered shell of interiors designed for fast replacement and fast removal.
Aircraft are not just metal shells. They are layered systems of aluminum, composites.
The aircraft does not vanish. It changes state. From skin to billet to product. By the end of teardown, the aircraft is no longer one object. It is precision alloy, salvageable hardware, copper, composites, and resale inventory.